Have you ever wondered how a city-sized machine powers itself under the sea for decades without refueling? Imagine a colossal structure, silently gliding through the inky depths of the ocean, operating for years without surfacing, without taking a breath of fresh air or refueling. This isn't a scene from a science fiction novel, it's a reality of modern warfare. This is the world of nuclear submarines. Nuclear submarines, these unseen powerhouses, have significantly redefined naval strategy. They are a testament to the technological prowess of the 20th and 21st centuries, playing a vital role in global defense and deterrence. But how do they manage to operate for such extended periods underwater without needing to refuel? The answer lies in the heart of the submarine, a nuclear reactor. This isn't your typical power plant. It's a compact, powerful energy source that uses nuclear fission to generate heat. This heat in turn produces steam, which powers turbines to generate electricity and propel the submarine. The fuel for this reactor? Uranium. A naturally occurring element with an impressive energy density. A small amount of uranium can produce an enormous amount of energy. This energy generation process is continuous and self-sustaining, meaning a submarine can operate for decades without needing to refuel. This endurance is a game-changer in naval warfare, allowing submarines to stay submerged for long periods, undetected, ready to respond to threats or carry out covert operations. But it's not just about the power. Nuclear submarines are a marvel of engineering, integrating complex systems for stealth, navigation, life support, and more. They are a microcosm of a city, with facilities for the crew to live and work for months on end. The nuclear submarine is an impressive achievement of engineering and science. It's a testament to human ingenuity and our ability to harness the power of the atom for peaceful purposes. It's an unseen power under the sea, a silent sentinel of the deep. Beneath the surface, these technological marvels are more than meets the eye. As we delve deeper into the world of nuclear submarines, we'll uncover more about these fascinating machines and their role in shaping the world as we know it. At the heart of a nuclear submarine lies its most potent and critical component, the nuclear reactor. Akin to the human heart that pumps blood, keeping us alive and kicking, the nuclear reactor is what keeps these underwater titans humming along. It's the powerhouse, the engine room, the very life source of these oceanic leviathans. But how does it work? Well, it all starts with a process known as nuclear fission. Picture a tiny particle, a neutron, barreling into a uranium atom. This collision causes the uranium atom to split, releasing a tremendous amount of energy in the form of heat. Now just imagine millions of these reactions occurring every second. The heat generated by these countless reactions is so immense that it's capable of turning water into steam. And it's this steam that plays the next vital role in the functioning of a nuclear submarine. You see, within the reactor, there's a primary coolant system filled with water. As the heat from the nuclear fission process rises, it heats this water, turning it into high-pressure steam. But here's the catch. This steam itself doesn't directly drive the submarine. Instead, it's used to generate electricity and power the steam turbines that propel the submarine through the depths. This process of heat generation and transfer is a continuous cycle, a never-ending dance of energy transformation, from nuclear to thermal to mechanical. And it's all happening right there, in the heart of the submarine, inside the nuclear reactor. It's astounding to think that such a complex process, a process that harnesses the very power of the atom, is taking place beneath the ocean's surface, in a vessel that's capable of circumnavigating the globe without surfacing. The nuclear reactor, with its intricate dance of energy transformation, is what makes this possible. So next time you picture a nuclear submarine cruising through the deep blue sea, remember that at its core, it's the nuclear reactor, silently and efficiently converting atomic energy into mechanical power. That's keeping this underwater beast on the move. In essence, nuclear reactors are the lifeblood of these underwater beasts. So we have our heat, but how does this heat propel a massive metal structure through the ocean? This is where the magic of thermodynamics comes into play. The heat generated by the nuclear reactor is used to turn water into steam. Now you might be wondering, how does steam move a submarine? Well, it's all about harnessing the power of steam to generate motion. Let's break it down. The heat from the reactor turns water into high-pressure steam. This steam is then directed towards a turbine. A turbine, in simplest terms, is a machine that captures energy from a fluid, in this case, steam, and turns it into mechanical energy. As the steam rushes against the blades of the turbine, it causes them to spin. This spinning motion is then transferred to the propeller of the submarine through a series of gears, and voila, we've converted heat into motion. But it's not just about getting the submarine moving, it's also about keeping it moving. After the steam has done its job, it doesn't just disappear. It's cooled down and condensed back into water, ready to be heated up by the reactor again. This cycle of heating, moving, cooling, and reheating is what keeps a nuclear submarine cruising through the ocean for months on end. It's an ingenious system, isn't it? This conversion of heat into motion allows a nuclear submarine to travel vast distances under the sea without needing to refuel. And what's more, because the propulsion system is powered by steam, it's virtually silent. This makes the submarine incredibly difficult to detect, allowing it to carry out its missions in stealth. So there you have it. The power of a nuclear submarine lies not just in its reactor, but in the way it uses that energy. By turning heat into steam and using that steam to spin a turbine, a nuclear submarine can glide through the ocean silently and efficiently. By harnessing the power of steam, nuclear submarines traverse the ocean depths. Living underwater for months presents unique challenges. How do submarines solve these? Well, let's dive right in and demystify how nuclear submarines generate fresh water and breathable air for their crew. Imagine you're many miles beneath the ocean's surface, submerged in a vessel that's both your home and your workplace for months on end. The outside environment is hostile, and you're entirely reliant on the technology around you for survival. This is the reality for the crew of a nuclear submarine. Water is a basic necessity for life, and on a submarine it's needed not only for drinking but also for cooking, hygiene, and cooling various systems. So, how do submarines generate fresh water? They use a process called desalination. This involves heating up seawater, then cooling it rapidly to condense it back into a fresh, drinkable state. The impurities, including the salt, are left behind and discharged back into the ocean. This process is powered by the heat produced by the submarine's nuclear reactor, making it a highly efficient system. Now let's talk about air. Humans need oxygen to breathe, and in the enclosed environment of a submarine, maintaining a breathable atmosphere is crucial. To achieve this, submarines use a process called electrolysis to split water into its two components, hydrogen and oxygen. The oxygen is circulated into the living and working spaces, while the hydrogen is combined with carbon dioxide, a byproduct of human respiration, to produce water and methane. The water can be reused in the electrolysis process, while the methane is safely expelled into the sea. In essence, a nuclear submarine is a self-contained ecosystem. It takes in seawater, and through a combination of desalination and electrolysis, it provides its crew with fresh water and breathable air. It's an ingenious solution to the unique challenge of living beneath the waves. Thus, submarines create a self-sufficient ecosystem beneath the waves. And that's just one of the many marvels of these underwater leviathans. Stay tuned as we continue to unravel the mystery of nuclear submarines. In the silent world underwater, how does a submarine see and stay hidden? That's the question that has intrigued many. The answer lies in sonar systems and stealth design. Sonar, or sound navigation and ranging, is the submarine's eyes and ears underwater. It emits sound waves that bounce off objects and return, giving the crew a sense of what's around. While sonar helps in seeing, the submarine's stealth comes from its design. The hull is shaped to minimize noise and water disturbance, making it difficult to detect. The exterior is covered with anechoic tiles that absorb sound waves rather than reflecting them back. Moreover, the nuclear reactor operates silently, unlike conventional engines, adding to the submarine's discretion. And the deeper the submarine goes, the harder it is to detect, thanks to the layers of varying water temperature and salinity, which distort sound waves. In the game of hide and seek under the sea, nuclear submarines are the masters. Today, we've journeyed into the heart of an underwater titan. We've explored the unseen power that lurks beneath the sea, the nuclear reactor that is the beating heart of these colossal machines. It's this reactor that enables the conversion of heat into motion, propelling the submarine through the depths with stealth and agility. We've also delved into the life support systems that make it possible for crew members to live and work underwater for extended periods. From the creation of breathable air to the purification of water, these systems are crucial for sustaining life in the harsh environment of the deep sea. We've looked at the stealth mechanisms that enable these submarines to stay hidden from prying eyes and high-tech detection systems. Silent and invisible, they move like ghosts beneath the waves. From harnessing nuclear power to maintaining life underwater, nuclear submarines truly are marvels of modern engineering.
Subscribe for more videos like this. Turn on notification and leave a like to help the channel out. Thank you for watching.